AI is completely rewriting the rules of software engineering, and honestly, most of us are still trying to play catch up. So today, we're going to break down the 3 fundamental pillars that you absolutely need to master if you want to build, test, and deploy software in this new world. Let's dive right in. And this quote, it just nails it, right? We're moving way beyond just using AI as a kind of clever coding assistant. The best engineers, the ones leading the pack, are now treating large language models as a core, powerful component in their stack, just like you'd treat a database or an API gateway. This isn't just about a new tool. It's a whole new way of thinking about how we build things. And this shift totally changes the game for us, for the developer. It's not about being the fastest typist anymore or the person who's memorized the most libraries. It's now about becoming the best architect of AI systems. You're the one who can skillfully direct and manage these powerful new components to build software that's robust and truly intelligent. You're not just writing the music anymore, you're basically the conductor of an entire AI orchestra. Okay, so our first pillar is probably the most immediate and high-impact skill you can develop right now: engineered prompts. And I'm not talking about casually asking ChatGPT for a quick code snippet. No, this is a legitimate engineering discipline where we craft our natural language prompts with the exact same rigor and precision as a formal technical spec. This right here is the core concept. The absolute best way to think about a prompt is to see it as a function call to a large language model, an LLM. All your instructions, the context you provide, the examples you feed it, those are the arguments you're passing to that function. The goal here is not to have a chat, it's to get a predictable, reliable output from the model every single time, just like you'd expect from any well-written piece of code. So how do we actually build a reliable function call? Well, we use a framework. The CO star framework is a brilliant mental model for this. You're not just asking a question, you're setting the whole stage. You define the context. Hey, you're a senior security engineer. You state the objective. Write a secure authentication endpoint. You specify the style. Make sure you follow the Pepe standard for Python. You even set the tone, define the audience, and, this is crucial, you dictate the exact response format you need. Like, give me a JSON object with these specific keys. And you can see the difference clear as day right here. On the left, you've got this lazy, ambiguous prompt. This leaves way too much room for the AI to just guess, to hallucinate and to maybe spit out some insecure or outdated code that's just going to become technical debt. But on the right, you've got an engineered prompt that clearly lays out the boundaries and constraints. The difference in the quality and the safety of the code you get back is just night and day. Now look at this. This is what a real production-grade prompt looks like. See how it leaves nothing to chance? It specifies the security context, which immediately primes the model to avoid common mistakes. It explicitly calls out constraints like rate limiting to stop abuse and using JWTs, JSON Web Tokens, for secure authentication. It even tells the AI the exact output format. You've basically wiped out all the ambiguity, forcing the AI to generate precisely the robust, secure code that you actually need. All right, let's switch gears and talk about our next pillar. But first, I want you to really think about this for a second. What's the single biggest bottleneck that always seems to slow down your team from shipping new features? For so many teams, the answer is always the same thing: testing. And that brings us right to pillar 2, self-healing tests. For decades, automated testing has been this notoriously fragile thing, a constant source of friction. But AI is completely revolutionizing this space, letting us build test suites that aren't brittle and flaky, but are actually resilient to change. Come on, we've all lived this nightmare, right? A developer changes a simple CSS ID on a button, and boom, the entire CI/CD pipeline just grinds to a halt. The build fails, all because some rigid test script can't find old button ID anymore. That's a brittle test. A self-healing test, on the other hand, powered by AI, it operates on a much higher level. It understands the intent. It knows it's looking for the submit button because of its text, its location on the page, and a bunch of other attributes. So when the ID changes, it just intelligently updates its own selector, and the test passes. No more false alarms. So how do you actually do this? The workflow is surprisingly simple. You start with an AI-native testing tool, and you just record your key user flows, like a login to checkout process. Now, the magic really happens when you define your AI assertions. Instead of just checking for the text success, you're verifying the visual correctness of the entire page. Is the layout right? Are all the elements rendered properly? Then you can actually test the heal yourself. Go in, intentionally change an element's ID, and then just watch as the AI-powered test adapts and still passes. It's amazing. Our third and final pillar takes us right into the heart of DevOps. Think about your current CI/CD pipeline. It's great at telling you when something has already broken, but what if? What if it could prevent failures before they even happen? Well, that's the whole promise of predictive pipelines. And this is the fundamental shift. It's a huge one. On the left, that's the reactive world we all live in. A deployment fails, alerts start screaming, and now you're stuck digging through a mountain of logs trying to find the root cause. The predictive pipeline on the right is a total game changer. It analyzes code and metrics before you deploy to flag a high-risk change, or it uses AI to instantly diagnose the problem after a failure, saving you hours of painful debugging. And the best part is, you can start doing this today by adding what we call AI gates to your existing pipeline. Gate 1, an AI code review. Think of it like an automated security expert that scans every single pull request before it gets merged. Gate 2, an intelligent log analyzer. When a build fails, it doesn't just show you an error, it actually explains the likely cause. And Gate 3, predictive scaling, which uses AI to understand complex traffic patterns and prevent outages that simple alert thresholds would totally miss. So, we have covered a ton of ground. How do you actually put all of this into practice? Well, let's boil it all down into a clear, simple action plan. So here it is, your action plan. Just 3 steps to start transforming how you work, starting tomorrow. First, level up your prompting. Adopt the CO STAR framework and start treating your prompts with the same precision you treat your code. Second, declare war on flaky tests. Go audit your test suite and start strategically swapping out those brittle selectors with intelligent, self-healing alternatives. And third, automate the most painful part of your job. Add an LLM-powered step to your pipeline to analyze and explain build failures for you so you can focus on fixing the problem, not just finding it. And that brings us all the way back to the central idea of this whole explainer. The next time you sit down at your desk to work, ask yourself this one question. Are you just writing lines of code, or are you starting to orchestrate intelligence? Because the future, it belongs to the orchestrators. Thanks for joining me.